Greetings, everybody. This is the first set of notes for rocks. We're doing a combined unit of rocks and minerals, and we're done with minerals. Now we're moving on to rocks. This is called ES 5.1, Rocks Part 1. As always, with the notes, you're going to be writing down everything in orange text, either handwritten or typed. And there's a catch-all slide at the end with everything that you need to have written down. So here's a picture that might look familiar to some of you. This is the mighty James River, looking kind of low on this particular day. A view under a bridge downtown, and a little bit of the flood wall there. But we're not learning about the river necessarily, we're learning about rocks, but the two are related in a few different ways. But what you see there when the river's looking low is a bunch of rocks. Rocks are all around us, beneath the soil, on the riverbed, under the forest floor, and under our city streets there's a layer of solid bedrock. Here in Richmond, we're on top of the Petersburg granite. The concrete that makes up many of our buildings is derived from naturally occurring rocky materials. This is a picture of a power plant. In Virginia, when we flick on the lights, some of the energy that powers our homes comes from burning coal, which is a sedimentary rock. But what are rocks? A rock is a solid, naturally occurring combination of one or more minerals or organic compounds. So for example, coal, which is pictured here, is made partially of dead organisms. So there's some organic stuff in rocks, sometimes. It can either be a combination of minerals, or it can be minerals and organic compounds. For example, quartz is a mineral, but a mix of 3 minerals together, quartz, mica, and feldspar, makes up a rock, granite. And that's a very common rock in Earth's crust, especially right around here. There's 3 types of rock: igneous, sedimentary, and metamorphic. The main difference between them is how they form. So you see here in the picture, igneous in a couple of examples, sedimentary in a couple of examples, and metamorphic in a couple of examples. So you need to write down this. It's each type of rock and how they form. So igneous forms from the cooling of molten rock. Sedimentary forms by the compaction of weathered materials. And metamorphic forms from extreme heat and pressure or chemical action. So we'll start off talking a little bit about igneous rocks. Igneous rocks form from molten rock, which is magma or lava, that cools and crystallizes into rock. This happens either above or below Earth's surface. Molten rock below the surface is called magma. Molten rock above the surface is called lava. There are 2 types of igneous rock: intrusive and extrusive. And you can see from the diagram, extrusive is on the surface of the Earth, intrusive is below the surface of the Earth. Igneous rocks that cool below Earth's surface with magma are intrusive. Intrusive igneous rocks cool off slowly and therefore have larger crystals, resulting in a coarse texture. So underground, as far as a rock's concerned, it's a little bit warmer, and so the crystals cool off more slowly and they get larger. Igneous rocks that cool on the surface of the Earth with lava are extrusive. Extrusive igneous rocks cool down quickly and therefore have small or no crystals, resulting in a fine grain or glassy texture. You can see on the right, obsidian is very shiny. That's a glassy texture of that rock. With the intrusive rocks, you can see the different minerals. The crystals are larger. With an extrusive rock, it has kind of more of a homogeneous appearance. Extrusive igneous rocks also sometimes have air bubbles, and that's because they're on the surface and they're exposed to the air. Uh, Intrusive rocks would not have air bubbles because they're not exposed to the atmosphere. So here's a chart with some of that information. So intrusive igneous rocks, that's magma cools and hardens below Earth's surface, underground, coarse texture, large crystals. Extrusive igneous rocks are when lava cools and hardens above Earth's surface, that's above ground, and they have a finer texture, small crystals, and sometimes they have air bubbles. And there's some examples of each. Granite is an intrusive igneous rock. Here's an interesting geological formation. It's Devil's Tower in Wyoming. So that's made of igneous rock. And at some point, that was underground. So how can a different kind of rock become an igneous rock? Any sort of rock can become an igneous rock. It can melt and then cool, and that makes an igneous rock. If you start off with a metamorphic rock or a sedimentary rock or an igneous rock, if you melt it and then cool it, it becomes igneous. So now we'll talk a bit about sedimentary rocks. Sedimentary rocks start with weathering and erosion of existing rocks. Sediments, like sand, gravel, and dirt, are transported through the water cycle. The water cycle and the rock cycle are related. Eventually, these sediments are deposited at the bottom of a body of water like a lake or an ocean. So, a river or a stream will carry the sediments until the end of its journey, which is where water accumulates like an ocean or a lake. In the lake or on the bottom of the lake, they're slowly compacted and cemented with more and more sediment getting dropped on top, solidifying over time into sedimentary rocks. And the result of that is called stratification. Sedimentary rocks always form at the bottom of a body of water, and usually they form distinct layers, which are called strata. And the further down in the sedimentary rock you go, the older that rock's going to be because the new layers form on top of the old layers. Here's an example of some stratification. And these sedimentary rocks are no longer under a body of water, but that's where they formed originally. There are three types of sedimentary rocks: clastic, organic, and chemical. Organic and chemical sedimentary rocks are sometimes called non-clastic. So you could divide it into two types, clastic and non-clastic, but that non-clastic category can be divided into organic and chemical. Clastic sedimentary rocks are made up of fragments of other rocks. Chemical, non-clastic sedimentary rocks are made from the precipitation of minerals. That means water evaporates and leaves behind the minerals. And then organic, non-clastic sedimentary rocks form from broken down organic matter. So there's the three types: clastic sedimentary, forming from the fragments of other rocks, and some examples: sandstone, conglomerate, and shale. Chemical sedimentary, forming from the precipitation of minerals, with some examples: dolomite, rock salt, chemical limestone. And then organic sedimentary, forming from dead organisms like coal, chert, or fossil limestone. Limestone can be either chemical or sedimentary. And that's another important resource in Virginia, mostly existing in what's known as the Valley and Ridge Province, which you see highlighted here in red. So why can you find seashell fossils up there? Because that area used to be underwater. Most of the rocks in the mountains of Virginia are sedimentary, which can include fossils. All right, metamorphic rocks. Here's a picture of some rocks that have been changed by heat and pressure. You can see that they form stripes sometimes, and the stripes get wiggly. So metamorphic rock starts with an igneous or sedimentary rock that is changed by the effects of heat, pressure, or chemical action. The original rock is called the parent rock. The metamorphic rock gets a new name. For example, if granite is exposed to heat and pressure, but not enough to melt it, it turns into a metamorphic rock called gneiss. Gneiss, that's pronounced nice. Granite is the parent rock, gneiss is the metamorphic rock, sometimes called the daughter rock. And here's a picture of granite and then a picture of gneiss. There's two types of metamorphic rock, foliated and non-foliated. Foliated just means it has stripes or banding. Foliation is often seen as banding or stripes because during metamorphism, the minerals separate themselves by density. So the stripes you see are the different minerals. Here's a picture of another metamorphic feature that's called slaty cleavage. I wouldn't worry too much about that right now, though. And another one called schistosity. It's another way that a metamorphic rock can look. Sometimes you get big crystals, big chunks of crystals. This is called a garnet schist. It's a metamorphic rock with garnet, a gemstone appearing. If a metamorphic rock is non-foliated, it has little or no banding and a homogeneous appearance. So homogeneous means the same. So there's no stripes here. There's no different minerals to see. So foliated metamorphic has stripes, bands, or other change in mineral texture. Examples, slate, schist, and gneiss. Non-foliated metamorphic has no stripes, a homogeneous appearance, and examples include marble and quartzite. So here's some examples of parent rocks and daughter rocks. When limestone is exposed to metamorphism, it becomes marble. When shale is exposed to heat and pressure, it becomes schist or slate. Granite becomes gneiss, as we discussed before, and sandstone becomes quartzite. So fossils are only found in sedimentary rocks, and it's important to understand why. Igneous rocks have to melt first, which destroys fossils. Metamorphic rocks are also exposed to heat and pressure, which also destroys fossils. So the process of forming a sedimentary rock doesn't involve those high temperatures, so the fossils can be preserved. And here's the catch-all slide with everything written down that you need to have in your notes. Feel free to pause it here and catch up on anything you missed. And that's it for the first set of notes in the Rocks section of the Rocks and Minerals unit, ES 5.1. I called it Rock Types here. That's different than the title I had at the beginning. Either title works. Rocks Notes Part 1 or Rock Types. All right, if you have any questions, feel free to send me an email.